So we're going to cluster this customer profile data. First of all, we need to determine the optimal number of clusters, not customers. Optimal number of customers is as many as you can possibly get. But what are the optimal number of clusters? Okay, well, I'm going to, again, I've selected just those three variables, and I'm going to go up to 10. So you could go higher. You know, there's 300 there. We could have potentially up to 250, 299 clusters. Again, it's no point doing 300 clusters because that just means one. That would probably mean one data point per cluster. But I'm picking a range of k between 2 and 10, and I used exactly the same code as before, except that I'm using the profiles data here rather than whatever it was I used before, the summary data. Almost exactly identical, and that's the visualization code. I'm not showing it here, but it's exactly the same. And although you probably can't see that chart very clearly, you can see the orange line, that's the silhouette score, obviously has a maximum here. You can see that quite clearly. And the elbow method, it hasn't got a very clear elbow, but if there is an elbow, it's also at the same point. And this is the value k equals 6. So both elbow and max silhouette score are telling us that k equals 6 is a good number of clusters. And it's usually, it's a good thing if those two methods agree. They don't always agree, but if they agree, that tells you that that's probably a good number of clusters for the data that you're looking at. So let's do a K-means clustering with k is 6. So again, I've got that code that we had before. I just need to change the k value. I need to change the selected, and I need to change the data that I'm looking at. But the rest of it should work in exactly the same way as example 1. And that will create a clustering. And then what do I do to visualize the clusters? Well, there's two ways I can do it. Either I can use 2D scatter plots like we did originally in example 2, but then I have to pick pairs of variables. So I have to pick age versus income, age versus spending versus income. Or I can do a 3D scatter plot. Now, if I do the trouble with 2D scatter plots is that the clusters are 3-dimensional usually. So we're taking a 3D space, that scatter plot that we've seen, and we're projecting it down onto 2 of those dimensions. And the trouble with doing that is that sometimes if the clusters are 3-dimensional, doing that is not going to reveal anything. So in these two cases, you can start to see some clusters. So if the clustering is orthogonal or at right angles to the viewpoint, then you will spot some clusters. And you can see in the second plot, when I do spending on the left here against age, there's 2 clusters here. So what are they telling me? They're telling me that if I look at the sort of people who spend more or less in the middle, so around about 40, 50 pounds, they can be clustered into 2 groups. Okay, one group is older people who are above about 45, and one group is younger people who are below 45. And that seems to be a good clustering because none of the other data points seem to fit in those clusters. There's no red outside those clusters, and no red or orange outside those clusters, and the clusters are quite separate. So that's quite good if we're able to do that. And in fact, we can do that again when we look at 2 different variables. So this one is spending versus income, and now I can easily see that the colors from those 4 clusters are particular parts of the region. So, for example, the green one is high income, high spenders. The purple one is high income, low spenders. Blue one is low income, high spenders, and the brown one is low income, low spenders, just by looking at the axes. The one in the middle, the people who've kind of got middle income and middle spend, they're not easily segmented that way. We have to use age to separate those out. So we can get lucky, and we can if the clustering is determined by 2 of those axes, then we will see that when we do these pairs of scatter plots, and that's what we've seen in both of those last 2 plots. But actually, probably the most useful tool for this particular data set is the 3D scatter plot, especially the interactive version. So if I run that, I think it's this example. This does all 4 plots. It does the 3 pairs, and then it does the 3D scatter plot. So there's 1, 2, 3, and then there's our 3D scatter plot. And as you can see, as I rotate it round, I can see that the orange and red are quite well separated. And if I line the axes up that way, okay, I can spot that those are all people with middle income, and red is the older group, and orange is the younger group. Alternatively, if I rotate it round that way, so I've got income on the bottom and spending on the left, then this is a reverse of what we saw before. Let me rotate it round. That's better. That looks more like what we had in the slides. So again, green is high spending, high income. Purple is high income, low spending, and so on. Okay, so that's quite a useful tool if your data happens to match that kind of configuration, because we can line it up and spot the different types of cluster, which I've labelled here. So high income, high spenders, high income, low spenders, etc. And there's the middle income, older people, middle income, younger people. Okay, so we can interpret that. We can actually get a good interpretation of that data. There's 6 distinct groups. There's the low income, there's the groups that are separated by income and spending. So low income, high spenders, low income, low spenders, and so on. And then there's 2 groups, the red and the orange, that are separated by, they've got more or less the same income, but older and younger people. But you can't, the trouble with this data set is you can't segment by a single pair of variables. So I can't just say, if I just pick the income and the spending, I get some cases where some can be old and some can be young. Or if I pick the middle income and the older people, some can be high spenders or some can be low spenders. So you can't pick any single pair of variables and that will tell you all about the clustering. You have to use these several comparisons of different pairs of variables to work out what the clusters are. Okay, so that shows you how you can do some interpretation of clusters, especially when they're in low dimensions like this, 3 dimensions that we're dealing with. To finish the lecture off, we're going to look at a data set that we can't do this with. We won't be able to deal with it today, but this is to kind of motivate next week's work on dimensionality reduction.